Hey YouTube, this is Anthony with On This Channel again. I had to split up the video. It was going to be way too long, so this is going to be part 8.5. How you like that? Anyways, on this one, we're going to test the wiring harness. Again, just like the last one, make sure you have your meter. Again, if you don't have one, do your best to get one. Send me an email if you have any questions on any of the settings or anything like that. But go ahead and have your meter, have the drawings, have a piece of paper and a pencil, write notes if you need to, and then as always our Sharpie and our tape for labels if you need to relabel anything or change the label. I'm just going to systematically go through this. Again, I explain very well what needs to be done and how we can do it. I'm going to do 2 tests. First test is going to be what I call a dynamic test, which means that we're not going to put voltage to it. We're only going to be going point to point to point with our meter and making sure that we have continuity and we don't have a short to ground. Our second part of the test is we're going to be hooking up some type of voltage source. I personally like to use 12 volt batteries for a battery drill. You can use a 14.4 battery, nothing higher than that. Anything higher and you take a chance on damaging some of the components like the relays or switch contacts. So without further ado, here we go on the rest of the video. All right everybody, we're gonna start on testing our harness. Before we get too far, I want to just talk about some of the tools that we're going to use. For our first test, we're going to do what I like to call a static test. And static means that it's stationary, you're not adding power to it. Dynamic testing means that you are adding power or motion or energy to it. So what we're going to do is we're going to use our meter, and I'm just showing you some of the leads here. So these are your standard leads, and I show them. They're just little pins, and we'll be able to use those. You can use these no problem. I have leads that have alligator clips on them, so they're easy to pinch on wires. You don't have to hold them. You can use the other style leads and just tape them on. That works perfect. Or they sell these all over the place, and they're really helpful. These alligator clip, these leads, they're amazingly cheap. I mean, you can buy these for maybe like $5 for this set here, and you can use them for testing of multiple different things. You can use testing at your house, testing on your car. If you're into computers, you can use the test and stuff on that. So again, we're gonna do on our static test, we're gonna be testing using the continuity and the ohm settings on the meter. So continuity just means that you're making a circle. So the meter, let's say that it's sending a signal out one of the leads, and then it comes back to the meter on the other lead, and it tells you you made a continuous or continuous connection. So I'm going to show you on this one. They typically look the same, the signal, or I mean the symbol anyways. So I'm going to go ahead and turn it on, and you'll see right there, just a series of lines, and it's supposed to symbolize sound or tone. So if I take my leads and put them together, we get a tone. I know we've talked about it in previous videos. The other one that we're going to use is the ohm, and that's where my channel's name is from. But you can see it's the omega symbol. Looks like a horseshoe. And when you put your leads together, you don't get a sound. With this meter, some meters they combine them, and that's cool. But you do get a measurement, and the measurement is the resistance or the inability of the electric to flow through a wire. 1, 2, 3, 4, 5, you know, even a little up is excellent. But if you don't have a meter that does continuity, they all do resistance for the most part, and it's perfectly. We're actually going to need that in our testing, and I'll explain it a little bit later. So let me turn that off. Also, what we were going to do is, because we're going to have to test after we do our static test, we're going to do a dynamic test. So we will add voltage to the harness, and we're going to make sure that our relays are wired correctly. They're going to pull in, they're going to give us the signals that we need. So what I've done is basically rigged up a key switch. I don't have the rest of our wires from the harness connected to it, and I'll explain later, but it's going to just be a key. It was off, but a key on in the run, and then you will have a start and then back to run. So it's going to be no different than your standard ignition switch that you'll have in your car. We're going to go over connecting this into the harness, and again, this is just temporary for testing, okay? What I like to use for our power is just a simple 12-volt drill battery or a cordless battery. You can use up to a 14.4 if it's a fully charged battery. We don't want to go any higher than that. Between the relays and everything, it's too much voltage. We don't need to exceed that. So I like to use these little 12 volts. They do hold quite a bit of current in them, but it's not enough to really damage if we make a mistake. Our static test that we're going to do is going to tell us if we have any short or a dead connection between our 12 volts positive and 12 volts negative. If we have that dead short or dead connection, that is going to really let the current flow through that wire and damage the wire. So you don't have to have all these, that's fine. If you don't have a battery, please do not use a car battery, a lawnmower battery, or even a high amperage battery charger, because they can potentially put out more power than what we need to test our circuit. We're just testing right now. We're not trying to power things up to start an engine. We don't want to put excessive amperage across our harness. All we're doing right now is making sure that key points have the voltage that we need, and the relays can pull in and give us the signals that we need for our harness. So what we're going to do next is I'm going to go ahead and get our harness set up, and I'm going to show you connecting that switch next, and then we're going to go over a couple of our, like I said again, we're going to do a static test, which means no power. All right, we're just going to check and make sure that our wires are connected the way that we need them to connect. All right, guys, we're going to do a test on our harness, and I'm going to call it a static test. If you look it up, static is used a lot in programming, and what it is you step by step go through it without the program actually doing its job or automating it or doing it automatically. In electrical, we use it to do it. We do a test where we're not going to add the power to it or not going to let the power run through the circuit. So we're going to call it a static test. And then we'll do a dynamic test after that where we are going to put voltage to it, and we'll energize our relays, make sure that they're working like they should. Again, I'm going to do it on the continuity first. There's be one test on the fuel pump, and I'll explain why in a little bit. We're going to use the ohm. So always first thing when you turn on your meter and you put it on whatever you want. If you're doing voltage, check it on something that you know for a fact has the correct voltage that you're looking for. You don't want to have a bad battery or a bad fuse in your meter mislead you on how it reads. So anyways, since we're doing continuity, we're going to check it with itself. So yeah, we know that's working. So we want to, very first thing is we're going to take and put these on the main leads that are in our harness. So the big red and the big black wire that we put in our circuit. It doesn't matter if you go red to black, black to red. It doesn't matter at all. The meter doesn't care in this particular test. Just to make things simple, we'll do the black lead on the black wire and the red lead on the red wire. And that's a good sign because we don't have a tone, which means that there is no shorts to ground, and a short to ground or a dead short means that the power that would be on the red wire and coming back on the black are touching, dead touching, and that's a bad sign. So now what we're going to do is I'm going to take the lead off of the red wire, and we're going to touch it on all of our relays on the black. This is the ground. We want to make sure that we have connection on all these. Need a little bit difficult to do. You have to push back in there. So there's one. I can get in here. Come on, baby. Again, sometimes these are tough to reach in there. Be patient with it. This is our fuel pump. That's right. So this one has a, it's going to read the coil resistance, and that's when you see that we're connected earlier. Maybe you didn't. The meter goes to 104, and so that's a resistance. It's not enough of a connectivity, or there's too much resistance, I guess what I should be saying. Too much resistance to show the continuity, even though if you look at the meter and I think you can see it says 104. So let me hold that up, and that's the ohms that it's reading. We go to the next one, which is our ignition. See how it reads 0? That's where just the continuity. And then again 0 on our EEC. You can try the other ones, which the NDS neutral safety is a totally different setup. We'll talk on that one later. But our fan relay, so there we go. We've got continuity from our ground or our black to the specific grounds that we need there. So now let's go through the other parts of the harness that are going to use the ground. One is going to be the O2, and if you remember correctly in the earlier section, the square part of the harness facing away from us is going to be a ground, our hot, and our signal. So we've got our ground, again, square facing away from me, ground, hot, signal, got our ground. One of the other ones that we're going to need is our mass air sensor, and with the tab facing you, it would be from left to right, hot, red, and then there's two red. Hot or red, black, which is our ground, and then two signal wires. So it would be second one from the left, 1, 2, and we've got our ground on that. So the other item to look for is going to be in our 60-pin harness. And I'm going to show you with the, just like earlier, with the tabs, two tabs facing to your left, sitting down looking at it, right? Looking at the top, you're going to have a 20, 40, and 60. Those were our grounds. If we go to 20, you don't have anything, and there's a reason why. All right, so it's because this ground loop or ground lug is connected to 20. This is done specifically by Ford. There's a phenomenon called a ground loop. You heard me mention it a second ago. It's where voltage can pass through the ground in a loop fashion, and you don't want that voltage to be able to be on the ground. If we connected all of our grounds together, we have that potential for a ground loop, and that's no good, no bueno. So this is specifically going to be grounded to the chassis or the frame or something that's specific. So 40 and 60 are going to be grounded through the harness. There's 40 and there is 60. So our grounds are good. We know that's good to go. What we can do now is we know that our red, we don't have any short on our red, and all of our power correctly goes through that. All right. The only thing that's not going to be would be on the switched side of these relays. And so what we can do is on our relays, we can go on the blue wire coming off of them, which is our switched wire, right? We can go in there and try those, make sure we're still on the ground, and then you can go to these. We shouldn't have anything. We don't want anything connected at all on that. And we don't have anything on that one. Nothing on that one. Nothing on that one. Nothing on that. So therefore, that means that we don't have a connection to ground on our switch sides, because the hot's going to switch through the relay. So we don't want it to switch and then it go to ground and have a short. So that shows that section is good. I'm going to go ahead and I didn't do the fan or the NDS yet. So now we've got that connected. We're good to go. So I want to go and we're going to look at the wires that connect on our, it's called the load side of our relays. The line side is the hot side, and the load side is the blue wires, or the wires that are going to be switched. So that's going to be our fuel pump, our signal, our run. It's going to be, hot in run, and it's going to be our hot in start, our O2 hots, and our EEC hots. So we're going to start with our EEC hots, and if we remember correctly, they were 57 and 37 on the drawing. If you need to go back and look, just refer to your drawing. But the switched hots off of our EEC, remember we connected it with a red through the harness. There's a big glob of reds that were right here, and we stripped a bunch of them out and then made our connection. So they're going to go to 57 and 37. So I'm going to grab my other lead here. and I'm going to go off the EEC. Remember, it's the blue wire is our load side. We're gonna put one of our meter leads in there, and then we're gonna go to 57, which remember 60 with that, so that would be 60, 59, 58, 57, and we have that. The other one is almost right across from it. It's 37, so you can count down. So it would be 40, 39, 38, 37. So we have our power off of our EEC relay, and that's, again, good. We're good. The other thing we want to look at now is our ignition. So our ignition, when the key is in hot, or I'm sorry, when it's run, it's going to turn this ignition on. So we want to get our lead in there. We can get it in there, all right. And then you want to find the distributor lead. It's going to be a long flat one. And it'll say TFI. Is how we labeled ours, but this is what it looks like. And our ignition is our red with green. So if you're looking at this with a tab facing you, it's going to be our third one from the left. So 1, 2, 3. So I'm going to take and stick my other lead in there. And we have our connection through the relay, or from the relay to our ignition. So we are happy with that. Next would be our fuel pump. So we can stick our lead in there, and this goes two places. It goes to the fuel pump, which I've got our wire labeled fuel pump here, and we know it goes there. It also goes to our, it's pin 19, which is a green with a yellow stripe, and this is the signal from, well, I guess it's a signal to the computer to say, hey, the fuel pump has voltage. So again, there's our 20, the tabs facing to the left, 20, 19, and we're good to go there. So next we have our O2, and this is labeled mass air O2, but the mass air is actually fed off of our EEC in the computer. So we're gonna get our O2 harnesses, that pigtails that we made, and again, ground, hot, signal. So we've got our hot, ground, hot, signal, and we've got our hot on our other one. So we've got power through all of our relays. I shouldn't say through. We have our power wires connected from our relays to the out source. So that's good for us too. All right, guys, we're gonna do a different test this time. And what I've done, you don't have to do this. There's gonna be ways around it, but I made myself a key switch, and this key switch is not your standard automotive switch. It's just something that I had left over from a lawnmower build that I did. But anyways, it'll let us test this in our run and start for the ignition side of it. You can obviously take these wires and just connect them, you know, just take and put them together and not have to go through this. This gives me an extra hand, so I can use one hand to turn these while I use my meter on the other hand. It just makes it a little bit easier for me. You don't have to go that route. You choose to do what you want to do. If you got any questions on that, just leave me an email and I can draw up a little drawing and send them to you. If you've got a key switch, you're like, hey man, I got this key switch and have no idea what I want to hook up to, send that to me, a picture of it, and we can talk about it. I can draw a little drawing and email it to you and give it a try. So now what I'm going to do is we're going to, since we've tested, we know there's no shorts on any of ours. We know our wires are connected to where they're supposed to connect. We're going to put some voltage to this now, and we're going to make these relays come on. And then we'll check through the relays if we've got power where we want it on our computer, power where we want it on the rest of our harness. So you do this a couple different ways. I like to use a little 12-volt battery out of a drill. You can use a 14.4 volt battery. I wouldn't go any higher than that. Voltage kind of gets questionable if you're going to tear anything up after that. You can also use a battery charger that has a very low amp draw, like 2 amps. I wouldn't go any higher than that. You don't want to push anything through this harness that can damage it. 2 amps is perfect for checking. We don't need anything higher than that. Please don't use a lawnmower battery, a car battery, anything bigger than that. That has a potential for a lot of energy and damage if we have a short or something, happens. Now these are fused, and that's a good thing. So we find something on the back side of it and we blow a fuse, we can search that out. But if you've done the test that we've done earlier and you didn't have any connection to a ground when we did that, then we should be fine and not have any issues whatsoever. So I'm going to hook this up and we'll start from there. Okay, so we've got our power source hooked up, and I'm going to show you. So this is when we're checking our power for this, which is DC, a battery. You'll see it's got one line over the V with 3 dots. That's DC voltage. That's what we're using. And I'm going to put this up here. Hopefully you guys can see the meter. So I'm going to put this on our key so we know that we have voltage. You can see 12.7. So that's good. Now when I turn this to the run, did you hear the relay click? I'm going to turn it off. There we go, you can hear it. So that's going to turn on. Turn it on now. So that's going to turn on our O2, our fuel pump, our ignition, and our EEC. So what we can do now is go through and we'll find the voltage. I'm going to start with my EEC. So remember, that way, tabs to the left, 5737. So we're showing 9.3 volts because we're flowing, there's no real current on this, and we're losing it through the wire, which is fine. And then we've got 9.3 also on our 37. So let's find our O2 harness. Just like we talked about earlier, square out. We've got our 9.3 and our 9.3. We got power there, which is what we want. Next, we want to find our O2. We want to find our mass air sensor. And again, with the tab facing us, our hot is going to be, or our 12 volts is going to be the far left. Again, we have our 9.3. It dances a little bit around 9.26, 28. It's completely fine. And then we're going to have our TFI, or our distributor. This is going to be our ignition. And we're going to have, remember, 1, 2, 3, with it in key, run. It's trying to leave me. So when I turn the key off, we drop power. I'm not sure, I think there's a glare on the meter. Sorry if there is. I turn it on. Key in the run mode. We've got our voltage turned off and the voltage is gone. I'm gonna turn the key on. You want this also when the key is in the start. So I twisted it to start. Our voltage did not drop away, which is a good sign. We know that we've not lost it. Now, there should be a wire directly next to it. It's gonna be our red with our blue. And you'll it's trying to dance around, but so we turn our relay on, nothing. When we hit our start, it goes down 0.2, let off. You'll see it drop and dance. That drop and dance is just voltage running through these other wires, and it's trying to pick up the wires next to it. It doesn't stay consistent or steady, so we know that's not consistent or steady on that wire. So we have power on our mass air and O2 through the relays. Our fuel pump we'll try, and I'll explain a little bit different. Our ignition, our EEC. So what we're doing with our fuel pump is that it's not really, you're gonna get the signal is more through the computer than it is. So when we turn the key on and we test our wire in the run position, we don't have anything on our meter, and I'm not sure if you can see it, but sorry for the glare, there's nothing. I'll take my lead off and nothing. And the reason being is that the computer itself tells that to come on. So you can hear it click, but we're not reading anything on those wires. Again, you'll hear the relay, and the relay is energized, and I'll prove to you that it is. So we're going to test on the red side of our fuel pump relay, and you see we have voltage there, and we're going to go to blue, nothing. Now our white, which is our signal to turn it on, we have voltage on that, so that means that the relay is closed. But why is it not? Because it's sending the signal from the computer, which is on pin 22. So the computer itself has to close a little switch inside of it to give the ground for the signal to close. So without the ground, we don't have a complete circuit, and without the circuit or the connection, voltage and current can't flow to make it work. So what we're going to have to do on this is we're going to have to take our jumper, and we're going to jump from our 22 to our ground. We don't want to, remember, this is a ground, not the hot. If we go with 53, 33, and we do it to 20, that's going to be a dead short, and we're going to have a problem. So what we're going to have is you want to have a little piece of wire. You can use any of those scrap pieces that we had earlier. I'm actually just going to use a piece of solder. So let's look at, this was our, remember, 20, 40, 60. We want to use 40 or 60. And so this was 22, so that's going to be, looking at it, it's going to be 21, 22. And you want to make sure you get it in the, and you'll hear the relay click. If you didn't hear it click, you're in the wrong one. So again, I'm going to turn our relays are on, and so I can have a extra set of hands here. I've got my jumper between pin 22 and 20, and now you'll see on my fuel pump that's off because I disabled the jumper. Now it's on. Off, disabled the jumper. Well, thought I did. So you can see now I disabled it. So we know that works. As long as the computer tells it to come on, that will come on. And guys, that's it. We know our relays, we've got our power. You notice we're totally not gonna connect our computer, and I'm gonna add that in at the very, very beginning. It's very important. If we have any problems, they're so sensitive that we don't want to burn our computer up. Obviously, they're not that easy to find anymore. There are places that rebuild them, but I don't know how easy it is to find those places either. So we've got our harness now. We know that we have our power, and we work. Our relays work when they're supposed to work. They power up the sections of the harness that they're supposed to when they're supposed to. So the next bid is going to be to try to get our engine to run. If you will have to be patient with me, I think you could see earlier from the condition of the engine, and I have quite a bit of work to get that a little bit ready. It does have good compression, and the oil pump looks good. I'm just going to have to do some cleanup and get some parts and pieces together before I can do that. So please be patient. Leave me an email if you got any questions. Leave a comment if you think this is good, bad, or indifferent. You know, I try to take the comments I've gotten, and if it needs to change it up. But guys, I hope you all are happy with the progress that we've made on our harness, and you're ready to rock and roll. So until next time, you all be careful, and I'll talk to you later.